Hi there, it's Ed here. I'm the CEO here at Sonderpods. We get asked a ton about the implications of building an ADU on a hillside. So I just wanted to take a couple of minutes to give you the cheat sheet and the secret code behind what you're really dealing with when it comes to building on a hillside. So let's get into it. So first of all, there's a few things that you need to think about. And I wanted to talk about the basic concepts of really what you're dealing with when it comes to a hillside. So what I've created here is my hillside. And then this box here is your Sonderpod. Now, obviously what I'm going to want to do is put my Sonderpod somewhere along the line of this hill. Now, what I'm going to want to do is make sure that I'm doing this in the most efficient way without triggering a huge amount of unnecessary expense. Now, there's a couple of things that you can do with a hillside construction. One is that you can set the unit into the hill. So if we go this way, but obviously what we need to do is dig the hill out. And if we dig the hill out, then we'll have to put a retaining wall at the back here. We'll have to do all the excavation. We'll have to get rid of all of the soils and so forth. So typically the further you go into the hill, the more expensive that gets. Now, alternatively, if you go this way and set it out from the hillside, then you see that this drop here, which we're going to call B, gets bigger, right? So therefore that's kind of the height at the moment. But if I go further out this way, then this drop of B just gets bigger and bigger and bigger. So obviously if you get something which is higher off the ground, then that can trigger additional expense as well. So at Sonderpods, what we try and do is really meet somewhere in the middle there to get the best possible solution, but also for the most reasonable cost. So there's a couple of magic numbers when you come to this. So therefore, we typically find that going into the hill a little bit and then using piers to make up the difference, because the secret is that if a retaining wall is 36 inches or below, then it doesn't require as much engineering and construction as a retaining wall that's above 36 inches. So the first key measurement that we're looking for is this measurement here. So if we're sinking the unit into the hillside, we would obviously have to create a wall that covers this distance. So therefore, we want to set that to make sure that A does not exceed 36 inches. Then what we're saying is that we know the size of the Sonderpod. So we're saying, okay, well, if we set this back into the hill so this retaining wall does not exceed 36 inches, we know then that that retaining wall is not going to be a significant expense. Then what we do is that we say, okay, we're going to have to then build a foundation to go from the bottom of the unit to grade here. So then what we're looking to do is measure B. And what we're looking for there is that our standard foundations can be up to 36 inches. So therefore, what we're really looking for is the ability to be able to put you on a hillside where we're meeting both of these requirements, where A does not exceed 30 inches and also that B does not exceed 30 inches. So if we've got those two things and we can make it, then that's generally when hillside construction doesn't become a significant additional expense, because we're typically using standard components that we use all of the time. Now, obviously, if you go further into the hillside and and A becomes greater than 36 inches, then it triggers other expenses. And then also B, if that exceeds 36 inches, then we need to do some other things. Now, the next thing that you need to look at is this hill, right? If the hill is made of rock, it's going to have a different level of structural integrity to a hill that's made of sand. So the next thing that we need to look at is, well, how significant does the foundation need to be below the ground? So typically we have our piers here. Now, what we need to really determine is, well, how deep into the hillside do we need to go with these piers? So therefore, if you've got very solid ground beneath you, then maybe the piers don't need to be particularly deep. But if you're in soft ground, then maybe these piers might need to go 15, 20, 30 feet into the ground in order to be able to create that structural rigidity that we're looking for. Same thing with the retaining wall. So therefore, you have the retaining wall, but maybe that retaining wall is going to have to dig much further into the ground to be able to get the support to hold back all of the rest of this hill. Now, The only way we can find that out is by finding out the rigidity of this of the hill, and we do that by working with a structural engineer, a geotech to be specific, and they do a thing called a soils report, which tells us what is the makeup of the soil around that. So what we need to do is understand, okay, well, what is the slope of the hill, and then how structurally secure is that hill, and then that will allow us to determine that. So moving through the steps on this, really, we've got a few magic numbers when it comes to sondapods. So therefore, if we determine that the slope across your site is less than 36 inches, then that's the cheapest thing that we can do. Our standard foundation will suit you there, and you're going to be at the lower end of the cost range. Now, the next level is that when you're between 36 and 72 inches, which there will be a slight increase, but this is where the retaining wall that we need to build is up to 36 inches. And then the piers, we can still use our standard foundations, because you've got up to 36 inches on the retaining wall and up to 36 inches on the piers. That equals 72. So therefore, there is a little bit more expense when we're between the range of 36 inches and 72 inches of drop across the site. But it's still not going to be crazy. Now, if you're above 72 inches, then it becomes exponentially more expensive. So one of the things that we look to do is, as early as possible in the process, is just to eliminate the risk that this thing's going to be above 72 inches. So the way we go about it, again, Sondapods is known for our no surprises process. So this is kind of how we go about it. The first thing that we do is that we'll do a parcel review. That will give us a site plan. We'll review the property and understand, that gives us basic topography to say, okay, well, how likely is this foundation to be, first of all, above 36 inches or even above 72 inches? So we'll give you a really good read about what risk you have of these higher costs immediately. This sort of answers 80% of it, and you'll know kind of which category you're in at that point. So there's not a lot of expense to understand exactly where you're at. Now, if we then find that, yes, you're over 36 or likely to be over 36 and below 72, then really the only thing that we can do next is to say, okay, we need a site survey and a soils report. Then we need to send that over to an architect, and then they can draw up the site elevations to then say, okay, well, can we place this building in a way where the retaining wall does not exceed 36 inches and the piers will not exceed 36 inches. It costs anywhere from $4,000 to $7,500 to do that. Most of it is just being paid to third parties, the site survey, the soils report, and there's a little bit of architectural fees. But once you're at this point, we'll be able to confirm that the unit will fit within that 72-inch limit, which again is which limits the overall costs. Now, if you find that it's going to be more than 72 inches and 6 feet, then you're at least aware then that you're going to be looking at some significant engineering costs, which will be $8,000 to $15,000 to actually produce an engineered foundation. And then secondly, that your foundation costs are going to increase exponentially as well. So typically, the first thing that we like to do is just to eliminate for our customers, to give them confidence that they're not looking at these exponentially increasing expenses, and that we give our customers confidence that they're within the limits of using these standard components, which keeps the cost of construction way down. So hopefully this was helpful, and let us know if you have any questions. Thanks a lot.